Hi, today on the workbench, this is a NuTone IMA3303. This particular one probably made somewhere around 1994, 1995 or 6 maybe. This happens to be a set that I rebuilt for a customer about 3 weeks ago. And it was kind of an ordinary run-of-the-mill, non-eventful repair. It had the typical sort of age-related issues that 3303s get when they get to be 30 years old. Hard to believe that they're that old almost, but they are. And also, in this particular case, it had a failing amplifier. So the amplifier was rebuilt completely. It was tested and everything worked great, and packed it up and sent it back to the customer. Her installer called me last week and said he was there putting it back in. He couldn't get any audio out of the radio or the intercom. The clock would light up. You could hear when you push the doorbell button, you could hear the relay go click, which means the chime module is activating. It would tune stations, but there was no sound. And we did a bunch of over-the-phone troubleshooting and couldn't come up with any reason that he could deal with there. And I told him to let me talk to the customer, and I told her the only thing I can say is pack it back up in the box we sent it to you in and send it back to me, and I'll take a look at it to see. And that's what I did this afternoon. Now, one of the things I hate more than anything else is redoing something I just did, because we do a thorough job and I was very confident it was what I refer to around here as an unremarkable repair. There wasn't anything about it that was weird or abnormal or tricky or difficult or confusing. It was just like, yeah, I know what the problems are. I know what needs to be done. Do the work, test it, it works good, send it back to the customer. When you work on a set for the second time after you have just worked on it and you did a very thorough repair on it, it's a little hard to know. You have to really think about what may be going on that caused the problem. So you double check all of the work that you did previously and it all looked okay. You take some measurements and you think for a while, because thinking is key. Couldn't find anything wrong with it. So then you start looking for things that seem to be more obscure. And one of the things that I like to do, and I'm going to switch this off now because we don't want to do this live on camera. Who knows, the smoke might come out. One of the things you start to do is you look for loose connections, or could be a crack in the board or something that's unusual, that 2 or 3% of problems that you see every now and then that create all kinds of havoc with what you're working on. One of the things I noticed, and I'm going to unplug it from the terminal board here so you can maybe see a little bit, and I'm going to take the speaker off of it because you already heard it play, so we all know that it works. That just makes it easier for me. And I think I'll take off the antenna, and I think I'm going to unplug the microprocessor board from the front so I can lay it down. Like that. So one of the things that is obscure but can happen sometime is this is the switchboard assembly. These are the room control switches that poke through behind the left-hand door on the front of the faceplate. You've got your intercom volume adjustment, your system volume, bass, treble, loudness, all that junk. Sometimes, very rarely, but occasionally, one of these transistors on this board will fail and it will compromise the audio signal input to the amplifier. It was a long shot, but the reality is it's one board, it's 3 connectors like that, and it comes loose. And I got a lot of these, so that's not a problem. So it's easy really quick if you have extras. You just go to the parts room, you open the tub, you grab another one that's exactly the same, because there are different versions of this and you have to have the right version for this model, and you come over and you plug it back in. The other thing about this you have to know is this cable, this is the audio signal cable. It plugs into a socket down there. These are the 2 cables. One is a ground for every remote station, and this is audio out for every station. Sometimes these can be dodgy. A fellow called me once on a service call, and what had happened was this plug over here had been partially unplugged from its socket, and then it didn't make the audio connection, and I said push it down and it snapped in place and it played. So that was some of the things we also did troubleshooting on the phone with the fella that was at this lady's house. Swapped out the board, powered it back up, still didn't play. wiggled the connectors just to make sure that everything was seated well and there wasn't any kind of problem. And what I noticed was when I wiggled these, for an instant, the radio played and it sounded normal. That's what I would expect. So then that's a clue. So what does that mean? Well, it could be a problem with the cables on this board. Now we play a game. The game is called What Are the Odds? What are the odds that in this lady's set that's been thoroughly rebuilt recently, the cables on her switchboard assembly are bad, and the one I went and got out of the parts room that's been sitting back there for who knows how long also happens to have bad cables? Not very likely. So you have to look for something, a commonality for the problem. What I thought it could be, and again, we go back to where it's a lot of visual inspection. Okay. Very carefully turn the board over, or maybe not so carefully. I just turned it over. Got the magnifiers, inspected all of the solder joints here very carefully. I inspected all of the traces. The traces are the green lines that you can see. That's where the copper is under the solder mask. Inspected all of those. I also inspected these two columns of diodes under here where they're soldered through. Now, these get checked on a normal 3303 repair because sometimes one of these will go bad and that will create all kinds of problems. One line of them had already been desoldered. The other side, not so much. So I decided the easiest thing to do would be I desoldered all, because if you had a bad solder joint, you don't, or what you shouldn't do, is you simply do not go through and resolder on top of all of the original solder. What you should do is you remove all of the original solder and then you resolder it from scratch, because that gives you a proper joint. So I did all of these, I did all of these, and I did these on this side because these had already been soldered when I worked on it a few weeks ago. So I did all of that. Couldn't find anything physically wrong, no cracks in the board or burnt traces or anything like that. Put it all back together, plugged the switchboard back in, powered it all up, did exactly the same thing. But we had a clue. We knew more than we knew before, because we knew that when you mess around with where the cables plug into the sockets down here, it came on and played for a second. Sometimes, and a valid test, and this will freak people out sometimes, and I've done this in people's houses. Here's another board. Here's another board out of it. This is an IMA3303. This board is pretty much toast now. It's a lightning damage thing. Anyway, sometimes you can have a problem. You can have a bad solder joint or a crack in a board that maybe you can't even see because it's so small. And sometimes what you do is you take the board or the set or whatever you're working on and you twist it and flex it. Because when you twist and flex and bend slightly, and I'm not talking about trying to be Hulk Hogan and snap it in half. I'm talking about, this is a diagnostic tool, okay? You twist and you bend and you flex, and you're looking for a change in what's happening. Sometimes, not related to this repair at all, sometimes you actually take a set and you actually give it the bounce test. You bounce it on the workbench. And sometimes you bounce it harder than that, because you're looking for a physical problem, a bad solder joint or some other thing that's causing the problem that you can't seem to identify. So on this set, push, twist, flex, and found a point that when you flexed, it played. And if you held it just right and kept your tongue at the right angle, you could hold it and it would play, and as soon as you let go, it would stop. That's an important clue, because now we know, okay, so it's an important clue mostly because now I know it's not something that I did, okay? It has nothing to do with my repair because, well, we did a little work down here, but I didn't think it had anything to do with me. So then I started looking more and more, and now what you do is you go from sort of the macro flex idea where you're doing the whole board down to more of a micro flex where you're doing little individual sections as much as you can reasonably do that. And then you move down to, let's start wiggling individual parts. So wiggle, wiggle, wiggle connectors, wiggle these, wiggle this, wiggle. And then I came here and I wiggled this right here, like this, and I pushed on it and it played. and when I let go, it stopped. So why was that? Well, let me get our example board here for a second before we get into the micro details of this. So this is same idea here. These are bridge rectifiers. There's 4 diodes in this one, there's 4 diodes in this one. This set has 2 power rails because it has 2 transformers. And these devices, basically what they do is they take the AC voltage from the transformers and convert it into DC voltage, which then goes to the power regulators to run the whole set. These are soldered onto the board, and as you can see here, if you look really carefully, you got one line of 4 joints and another line of 4 joints because there are 4 pins on each one. And that's where the problem lied. So here's a brand new one. And you can see it's got the body of it just like the ones you saw. And this is, since it hasn't ever been used, it has the leads here at the bottom, and they're very long. They're probably about 3/4 of an inch long. That's the way they come. You mount them on the board, you solder them in place, and then you clip them off. So that's a brand new one, just like the ones I put on the set over here. Here's one of the 2 original ones that I took out. And here's the other one. And you might think, well, those look exactly the same, but they don't. They do have shorter leads here because they were mounted on the board when the board was manufactured, and they were soldered and then snipped off. However, this one, not so much a culprit. This one's probably absolutely fine. But if you're going to replace one, you're going to replace both because that's best practice. These are not expensive parts. I don't remember exactly how much they cost because I've had the ones in the tub forever, but we don't use them that often because they're very reliable. However, you're simply not going to change one and leave the other old one because that's just wrong. So we'll put that in the cup. Here's the one that was actually the culprit. And what will be hard to see, and I'm going to see if I can make this easier for you to see. Maybe we'll do it like this. That might be a little better. Or maybe we'll do it like this. The problem with this is it has to do with the leads. So the leads are not all the same length. And what I'm going to do is I'm going to sit it on the edge of the block here, because this is hard for you to see because it's so small. And I'm going to take my red Sharpie and I'm going to draw a little line underneath the bottom of each lead. And while it's a little hard to see, if you look really carefully, you'll see that as you start from this side and move this way, the dots get higher and higher and higher because the leads get shorter and shorter and shorter and shorter as they go across, which means that when this was mounted onto the board, it may have been somewhat crooked or something. I don't know exactly why that would have happened, but it did. So what does that mean? Well, what that means is now it's time for a little drawing. So here's the circuit board. This is the edge of the board, the thin dimension. This way, the thickness of the board. Not this way, not this way. The thickness top to bottom. In the board, there are 4 holes. And the leads of the device go down through the holes. And on the underside of the hole is where it gets soldered. That's these 4 right there. If the leads are long when they're put through, like this, they get soldered, so you have a mound of solder around each lead, and then they're snipped off. Snip, 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 snip. And you're all good, because you've got a fair amount of lead inside the mound of solder to make the connection, to hold it in place, and all the world's happy. However, when you have your circuit board and you have your leads that stick through, if the leads become progressively shorter and shorter, what you end up with is leads that are barely even with the bottom surface of the circuit board. So when you solder it, you solder this one, you got a nice mound. When you solder this one, you got a nice mound. When you solder this one, you make a mound, but there's no lead sticking through the top of the mound. So the only place that maybe you get solder is on the very end tip of the lead. So what you end up with is, if you look at it from the bottom perspective, you have a hole in the board for the lead to go through. You have a solder pad around the board, but the lead is only very evenly with the top of it. So when you solder it, the solder is just sitting on the very top end of the lead right here. That's not good enough. And that's what happened in this set. Two of the leads, which are very short, were not protruding at all through the mound of solder. They were very lightly soldered on the very end of the lead. And perhaps it was okay that way for almost 30 years. And perhaps you developed a solder crack with the shipping from Texas to us and us back to Texas. Or it was just one of those things that happens. I do explain to customers periodically when it comes up that sometimes things just happen. It's not something that you typically look for. I'm not looking at every single solder joint on every single connection on every single intercom that I work on, because it's not practical to do that. If you look at the back of this board, there are hundreds and hundreds and hundreds of solder joints. And you can't really sit there and look at every single one to make sure every single one is perfect. Because if it works and you do your job and it's repaired and it works, that's what you got to do. That's the job. Now, what this does mean is that from now on every 3303 that I work on, and perhaps for every 4406 that I work on, because they're similar designs, I will always look at these, because this is a total pain in the neck. This is a stupid problem that had a relatively easy solution once you figure it out, but it's totally annoying. I have to work on something that I just fixed. Plus, it's annoying for the customer because she had to send it back to us and then wait, and then the other fellow's got to come back out and put it back in and all of those kind of things. And it's not cool, okay? It's not cool for that kind of thing to happen, and we try really hard to not let it happen. This is a good example of how it's supposed to look. The other one, not so much. So this video, I think, should be entitled, this is a chapter out of a book called Welcome to My World. This is what you face when you repair things for people sometimes. You have these weird, strange problems that are not obvious, that you don't necessarily think of, because why would you? It's supposed to be manufactured correctly. It's not a problem I think I've ever seen before. So it's the very first one. But now you have to be on guard for it on every single one you work on, because I don't want to do this again. That's it. Now it works. You heard it play. I got to put it all back into the faceplate. I'll let it run for a day or two, it's kind of like belt and suspenders. You want to try to tip it in our favor as much as possible before I call and tell her it's all fixed, and I'll send it back. And I'll give her a link to this video so she can see that I'm not, out of my mind and crazy. Hope you found this interesting, and maybe for someone it'll be helpful. If it is, give us a thumbs up on YouTube, thumbs up, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.